Thank you. All right, good afternoon, everybody. Thanks for joining us. Hope everybody is okay after last night's storms. Today, I'm going to be focusing on considerations for post herbicide applications. Most of our crops are in. Hopefully, we all got our pre's out there. So it's never too early to start thinking about your post-emergence programs, and that's what I'm going to be focusing on today during my presentation. I'm just going to put the pointer here real quick. There we go. Just a quick announcement here. If you got a pen and a piece of paper on you, we have a date set for our Arlington Agronomy and Soils Field Day. That's going to be the last Wednesday of August, so August 28th here of 2024. And the theme for our field day this year is going to be From Data to Action, Transforming Big Data into Informed Agronomic Decisions. So it's just an advertisement here. So you put the date on your calendar, and hopefully you can join us on August 28th at Arlington Agricultural Research Station. More information and details will be coming out in the next couple weeks. This is the outline of today's presentation. This is a question I've gotten the past week or so here. So my soybeans are up, and I haven't sprayed a soil residual herbicide yet. What can I do? So I'm going to discuss that a little bit. The second aspect I want to discuss today is the importance of early season weed control in corn. Okay, so we can manage herbicide-resistant weeds, but also optimize our corn yields out there. It's very important to do a good job controlling weeds early season in corn. So I want to discuss that today a little bit. Then I want to switch gears and I want to talk about stewarding 2,4-D, glufosinate, mesotrione, and dicamba in our corn and soybean production systems. We're putting a lot of selection pressure on these herbicides. We have resistance evolving, so I want to discuss things that we can do from a post-emergence application standpoint that we can lower, the selection pressure for resistance evolution on these herbicides. And then lastly, I just want to give you all a quick update on where we stand with the herbicide resistance screenings from all the samples that we got last fall. So that's my outline here for the next 25 minutes or so. So back to the initial point of my discussion here today. I planted my soybeans. I had the best intention of putting a pre-emergence herbicide shortly after planting, but it's been really wet. It's been a really windy spring so far. I kept planting and I couldn't get my pre's out. And it just so happens that my beans are up, right? I think that's happened in some fields out there. So what can we do? I still want to put a pre down. I have water hemp that's going to be coming up right now. Our water hemp is emerging in Janesville at the Rock County Farm. As of this morning, my students were at Brooklyn, and we just saw the first water hemp of the year there breaking through. So water hemp is actively germinating in Wisconsin right now. So we either want to have a residual herbicide active in soil already, or we want to be spraying a pre out there to help us control water hemp. So what can I do, right? I didn't put a pre. I had a plan. Let's say I wanted to put a Spartan base or a sharpened base program as part of my residual. I didn't do it. So now those are no longer options because my beans are up. Rodrigo, what can I do? My main recommendation at this point become kind of a three-way mix. What I tell folks to do now is, okay, your beans are up. I still want to see multiple sites of action. So from a group 14 herbicide, an option that gives residual that can be sprayed after the beans are up is Flagstar or Fomesafen. So I would start there. I would make sure my program, if I'm spraying shortly after the beans are up, that I have Fomesafen. I would make sure I have a group 15, whether that's going to be metolachlor or Duo, Acetochlor or Warrant, Outlook, or Zidua, that's up to you. Okay, but I would mix one of these 15s with Flagstar. Common options out there are prefix, right? It's already a premix of Flagstar and Duo, or you have Warrant Ultra, which is Flagstar plus Acetochlor. Those are quite common and cost effective from an early post residual program. But one thing I also encourage folks to do is bring, let's say, a group 2 herbicide. A common one would be Pursuit, right, as part of that three-way mix. That is a very flexible program. There's 3 herbicides, Flagstar, a group 15, and then Pursuit. You can either spray that pre-emergence or shortly after the crop is up and going. The reason why I still recommend the pursuit in there is obviously not for the water hemp control, but that pursuit in there really helps with small seeded grasses and large seeded broadleaves. Okay, some of our giant ragweed out there, common ragweed, velvet leaf, and so on. So this three-way mix is quite flexible, and if deployed shortly after crop emerges, will do a good job providing good residual control of the weeds that are yet to emerge. So that's the first point of today's presentation. The second point I want to discuss, and I think to many of us, this is, it's common knowledge, but I don't think it's true for everybody. Because I've been traveling around the state this winter here, and then one thing that I heard quite often was, from growers, it's like they like to see they till the ground, they plant their corn, and then they like to see the weeds coming up. And when the weeds are established, that's when they like to spray their herbicide program in corn. Okay. The problem with that is that corn is really, really sensitive to early season competition with the weeds, okay? And sometimes there are plenty of resources. There might be enough water, there might be enough nitrogen and other nutrients in the soil for all, the crop and the weeds to continue to grow. The catch here is that a corn plant can sense when there are other plants growing near it. Okay, it's amazing, that mechanism. So through light reflection, once you have light hitting a plant, there's light reflection, and corn can sense when there is something else that's green growing near it. And when it senses competition, it tries to take off. And when it tries to take off, it gives up on yield. Okay, so when you have scenarios like the one in this picture here is a disaster, and you're giving up on a lot of yield. So you want to start your corn crop clean. You want to stay clean. That helps with herbicide resistance management, but it also helps you optimize the yield potential of your corn crop. Okay. And then as I was preparing for this seminar today, I ran across this JAM. This is the publication that came out, years ago out of Iowa State University by Dr. Hartzler, but it really helps me convey the message. So this was a really neat study. They tilled the ground, they planted the corn, and then they spreaded annual ryegrass, simulating a scenario where they were dealing with grassy weeds, okay? And what they've done here, though, the first treatment here is kind of what their control check is. So they sprayed a harness was a pre-herbicide, and then they did two post applications because they wanted to keep those plots weed-free. Okay, so those were the weed-free plots, and that's the yield there of your weed-free plot. The other treatments, they played a little bit at when they sprayed the herbicide program. So the second treatment here, what they did is they didn't put a pre, and then they deployed two applications of Roundup. Okay, and they used Roundup in this case because the target weeds that they were working with were grasses highly susceptible to glyphosate. Okay, so they got really good control with two passes. However, but because they didn't start that season clean, and that initial application happened at the V2 stage, they gave up 5% yield already. Okay, and you can start making the math in there. By delaying 5% yield, 450 corn, what is the amount of money you're losing by delaying that? As they delay another week, and instead of keeping that field clean from the V2, they wait to spray until V3. All right, at that point, they already lost 13%. But this is where it gets fascinating. Let's say starts raining, and then I cannot get to the field until my crop is at that V4, V5 stage. This is what happens, okay? So if you delay by a week that control, this is what they did in this experiment here. They deployed that application at V5. They lost substantial yield. They lost about 75% yield, okay? So this is, just wanted to describe here how sensitive corn is to weed competition early on, and we don't want to be delaying those applications to control established weeds. So what are their conclusions here? Between the V2 and V4 growth stages, an average of 1.1 bushel was lost per day in this experiment in Iowa, okay? However, when you waited to do a later application between the V4 and V5 now, you let that weed compete with the crop for a little longer time, the average yield loss was 17 bushels per day. Okay, so when that crop got to the V4 stage and you allowed those weeds to continue to grow, they were losing 17 bushels per day. Okay, and that's quite dramatic. All right, so the timeliness of our applications to clear those fields from weed competition early on is incredibly important in order for you to optimize your yield of your corn crop. Okay, and this publication is available in the link here if you want to take a look later. With that said, this is an experiment that we've been doing. This is a systems trial. We're now in the 6th year of this experiment, and I selected the 2022 data from Arlington to present. In this trial, we have multiple ways of managing our soil. Okay, we have conventional tillage year after year after year. We have 6 years no-till now. We had cover crops that are terminated about 10 days before planting our cash crop. We have a scenario where we plant green and we kill that cover crop the day off. We have a scenario where we chop the rye for rye lip. So we remove the rye, we plant the crops. And then we have a scenario where we plant green and we let that cover crop continue to grow for 2 additional weeks in tandem with our crop. Okay. The first thing that we're learning here, and back to this critical time of removing weeds in corn crop, is this first piece here. Okay, so where I have excellent weed control, my purple bars here, I didn't see different yield potential of my corn crop regardless of whether I planted green and terminated, whether it was no-till or conventional tillage. But when I let the cereal rye cover crop continue to grow after my corn crop was planted, that was bad. Okay, we lost 30 bushels, 20 bushels right there. So that's a bad deal. That's why we say the moment you're planting your corn crop, if you have a cereal rye cover crop out there, you want to make sure the cereal rye cover crop is terminated. We don't want to have that early season competition between the cover crop and the corn crop. Corn is really sensitive. Soybeans can take it. Corn cannot. But the second important part of this slide is look at the difference between the brown bar and the purple bar for each one of our soil management strategies. The difference between these 2 bars within each soil management strategy is the yes or no use of a pre-emergence herbicide. Okay, purple bars, we put a residual herbicide with our burn down program. We started the experiment clean, weed free. The difference is that in the purple bars, we had a residual herbicide. So when we had a residual herbicide, regardless of our soil management strategies, between 30 and 50 bushel higher yield. Okay, now you make the math in there. Can you justify putting a pre-down, starting clean, and then doing a good job cleaning your weeds post in a 2-pass program in corn when you can save about 40, 50 bushel per acre? I think you can, but that's something that, is depending on what the system you're working with. But that's quite fascinating, okay? So now that I'm talking about pre-emergence herbicide, I want to discuss resistance management because I think that's a good segue. This is a paper that was just published last fall in the National Academy of Sciences. Usually weed scientists don't publish there, but this is a really neat, impactful research that we had a chance to be a part of. Our colleagues at the University of Illinois led it. What they did, they collected data, okay, from all the herbicide evaluation programs across the Midwest, United States, and parts of Canada. And then they looked at weed control trends for 25 years, from 1996 until 2021. Okay, so you're going to see 2 figures in front of you. On the left is control, weed control over 25 years. And on the right is variation in weed control, okay, over the same period. There are multiple species here: velvet leaf, Palmer amaranth, water hemp, common rag, giant rag, lamb's quarters, and horseweed. Within each figure, you're going to see 2 panels. One is where we looked at control of glyphosate alone. Okay. On the right side panel are the treatments that had a pre-emergence herbicide applied at the time of planting, and then glyphosate was deployed post-emergence. What we're learning from this 25-year experiment, massive data set, is that over years, glyphosate has lost efficacy. And that's not surprising to any of us, okay? But what I want to say here, that's not only happening to water hemp, horseweed, giant ragweed, that's happening to all species that were evaluated in the study. And not only herbicide or glyphosate efficacy has declined over the past 25 years, here's variation in control, okay? Over the past 25 years, the variation in control with glyphosate post-emergence has increased substantially. So we have lower efficacy and we have a lot more variation in control. And that's not what we want to see. What's very surprising with the study is by simply adding a pre-emergence herbicide as part of this control program, we kept glyphosate efficacy, okay? Glyphosate remained effective in the plots where pre's were applied, and the variation remained low, okay? So this is quite fascinating. We cannot go back and fix this, but we can take this message and think about the technologies that we have now and deploy this knowledge moving forward, okay? So what are the conclusions of this study? Results from this study show that when used alone, glyphosate efficacy decreased and became more variable. That's what I just showed you. Even for a tactic that was initially, back in the mid-90s, highly effective, the pace of weed adaptation should not be underestimated. Our weeds are constantly adapting. The second conclusion here is that, fortunately, even a simple approach to diversifying a weed management system, such as including a labeled pre-emergence prior to glyphosate post-emergence application, slows weed adaptation. And that's what we want to see out there. We need to do everything we can to slow down adaptation of our weeds to our post-emergence herbicide programs. With that said, here's something else we can do to slow down herbicide resistance evolution when we're deploying a post-emergence application is look at the timing, okay? We have a fascinating experiment going on in the greenhouse right now. I've been going to the greenhouse in a couple of times a week now to watch this experiment that my group is conducting there. It's fascinating, okay? We're learning a lot out of this. So we're looking at multiple things. We're looking at different chemistries, mixing different chemistries, but one of the main pieces is what you're seeing in front of you, the timing of application. Okay, so we have 1, 2, 3, 4, 5, 6 different timings of application of our multiple herbicides that we're evaluating. Our initial timing is when our weeds are 1 inch, and this is the dream right here. Okay, keep that in mind. When you see that weed 1 inch, that's phenomenal time to be deploying. I know that doesn't always happen out there. Really good. 2 inches, we can still get good control according to this greenhouse experiment. 4 is our labeled recommendation for the max weed size. When we're seeing 4-inch tall water hemp, I think we're already losing the battle. Okay, 6-inch is getting too tough. 8-inch and 10-inch, forget about it. Okay, so timing really, really matters. And it's what's fascinating about all this is that, you know, in our greenhouse or under ideal conditions here, water hemp is growing about 1 inch every 2.5 days. Okay, that growth is not consistent, as you're going to see. From 1 to 2 inches, it took about 5 days. To go from 2 to 4 inches, it took about 6 days. But then from 4 to 6, it only took 2 days. So it's not a, you know, a consistent growth. It's got these jumps, okay? And that's what we're seeing here, okay? But anyways, on average, every 2.5 days, 1 inch. So let's say we get rain just like we got last night and we're out of the field for 5-6 days. That's all it takes from an excellent program to not deliver the excellent weed control you want to see out there, okay? So we want to try to be there as early as we can in order to catch this weed small. So that's the first piece. The second piece here, I'm going to talk about some of the preliminary visuals that we're seeing, okay? So we have, in this particular experiment I'm going to describe today, Dr. Mobley here, he's comparing Enlist 1, okay, so 2,4-D choline. We're going to be looking at Liberty or glufosinate, and then we're going to be looking at mixing Liberty and Enlist 1, which is a common recommendation out there right now, okay? And then we have 2 populations for each herbicide. We have a confirmed 2,4-D resistant population from Wisconsin. Okay, that's the population 101. This population, Felipe Faleco in our lab confirmed it to be resistant to 2,4-D. And then we have a non-sensitive 2,4-D population, which is the 106. Okay, so the plants that you see on top here, these are untreated check. These pictures were taken a week after applying. So remember, these plants here were applied when the water hemp was 1 inch tall. A week later, I come and, you know, Nicola took these amazing pictures here for us, so I can show them to you today. When we sprayed water hemp that was 1 inch tall, remember, very small, this 1 inch tall plant here, our control with the label rates of Enlist was excellent. Even our resistant population, we were able to control, okay? You look at Liberty, excellent control as well. Check this red box. Liberty did excellent on those 2 water hemp populations. And here's the mixture of Enlist and Liberty. So at 1 inch, these 3 programs performed quite well. That's what we want to see. Now we move into 2-inch plants. When we sprayed, they were 2 inches tall, and then we take pictures a week later. The story is changing here, okay? Here you can start to see this 101 population is not being fully controlled with Enlist 1, unfortunately, okay? And even our sensitive population, 3 plants got fully controlled, but you have this 1 plant that's twisting in there, and I'm unsure whether it's going to come back or not, okay? Now you move on to the Liberty. Liberty cleaned them. okay? Whether you do Liberty alone or Liberty plus Enlist. And that's why we're seeing this recommendation of moving or mixing, Liberty with Enlist One, because Enlist One alone is struggling to control some of our water hemp populations out there. So we need the help so we can slow down resistance. But we all know that when we're only using glufosinate or Liberty, we also have our challenges, right? Because glufosinate is really finicky as far as environmental conditions go. And that's why we're hearing about this mixing strategy, putting these two herbicides together to postpone resistance and enhance control. But 2 inches overall, okay. Here's what starts happening at 4 inches, okay? There's a lot more green here in this picture. At this point, I mean, it's borderline for me. If you hit everything right, yeah, you might get good control, but I think we're putting a lot of pressure when we're spraying this herbicides at 4-inch tall water hemp, okay? I'd rather see it smaller than 4 inches, okay? Our resistant population here not being controlled with 2,4-D. Glufosinate overall doing a good job. The catch is that you burn things with glufosinate, but if you don't get full coverage, they regrow back, okay? And this is what happens at 6 inches. Now you see a lot more green. Now we're losing control. So we have 2 great herbicides, but we're deploying them a little too late on our weeds. Unfortunately, they're not going to be delivering at the level of control you could have achieved had you sprayed sooner. So that's very important, okay? And the other thing that I want to say here is that you start taking a closer look at some of these plants that you think you killed them, and this is what you see. So one recommendation for you, if you sprayed one of the herbicides a little later, go to the field and check the water hemp plant. If you touch the base of the water hemp plant and it's still green and healthy, and you start seeing little buds like this one that I'm pointing at in the corner of the screen, that plant is going to grow back on you, okay? And that's concerning for us here. And then as far as what happened with the 8 and 10, stay tuned, because this experiment is still happening in the greenhouse, and we hope to have that available to you soon here in the next couple of weeks. But the main message, glufosinate can really help with effective weed control. We're putting too much selection pressure on our 2,4-D. And the other point is when we're spraying these herbicides in our soybean systems, we need to spray to small water hemp. 4-inch tall water hemp is already getting a little too big. Let's try to focus on 1-2-inch tall water hemp when possible. I understand the limitations, but when possible, let's do that. And that's not wait too long to deploy a POST program. Now I want to switch here into our corn herbicides. This question I got multiple times last year, and it was a question/comment saying that mesotrione or Callisto wasn't providing appropriate levels of control of water hemp post-emergence in corn. Okay, last year we had the drought, and that can play a big impact on efficacy of Callisto. But I think we're putting a lot of selection pressure. Most of the cases when I asked what was sprayed, the mixture was glyphosate, metolachlor, and Callisto. So when you're spraying these 3 herbicides, post-emergence to corn, where you have established water hemp, again, glyphosate, we have resistance in most of our Wisconsin water hemp populations to glyphosate. So glyphosate is not helping with water hemp control. The metolachlor is only going to help with what's yet to emerge. So who's doing all the work here? It's actually the mesotrione. Okay, so we're putting a lot of selection pressure, and this is some of the work that we're doing in the greenhouse right now, work by Felipe. We do have some populations that are not properly responding to Callisto post-emergence, and that's really, really concerning. Rodrigo, going into the season, how do we overcome that? The way is to look at synergistic partners. First, adjuvants. You want to put the right adjuvant load out there, but you also want to look at other herbicides that can help you. For instance, it's widely known that mixing mesotrione with atrazine helps enhance post control with both herbicides, atrazine and mesotrione. All right, Rodrigo, I'm in an atrazine prohibition zone, or I don't use atrazine because half of my fields are atrazine prohibition, half are not. What can I do? If you cannot use atrazine, the recommendation is that you mix that with dicamba, whether it's Diflex or Status, so you don't have that mesotrione acting alone. So mixing mesotrione with a dicamba-based product can help, or some research that has been published out of Canada, and we're going to be doing some of this work here in Wisconsin this year, is looking at alternative replacements in these areas where atrazine cannot be used. And one of the options that we hear commonly is bromoxynil, or Moxie, okay, is a commercial product out there. So it's a photosystem 2 inhibitor. So mixing bromoxynil with your mesotrione, enhancing control of water hemp post-emergence. That's data that has come out of Canada, some studies here in the US, And we're going to be doing that this year at Brooklyn, Waterham, and Janesville giant ragweed. So stay tuned on that. Again, looking at synergistic mixtures in there in order to help the Callisto. We cannot afford having widespread resistance of Waterham to mesotrione in the state of Wisconsin, because then our options are going to get really, really tight. Okay. And then lastly here, when deploying an application, even if you're spraying at the right time, is pay attention to the weather conditions. Our group's starting to do a lot more work looking at deposition of herbicides during an application. So I'm going to play a quick video here. And I'm going to play that again and just look at the spray pattern. So this is an experiment that Zaim did last year, and we're going to be doing again this year. Look at all that movement, the displacement of your spray pattern, okay? And this was 3 mile/hour wind. We need to be very careful with wind during application, because that moves our spray pattern, and we're moving our spray pattern. We have concerns about drift, but we're also reducing the amount of herbicide that's getting to the target, and that's problematic for resistance. The other thing our lab is investigating is how crop canopy and weedy canopies can impact deposition. And the main thing that we learned from the study by Nicola here is that if you have a small weed growing underneath another larger weed or adjacent to your crop row, there was a 4-fold reduction in the amount of herbicide getting to those little weeds by the crop or by underneath other weeds. And that's problematic, because that's what we see then, okay? This weed here was underneath this plant, so we killed the big plant, but we shielded the little one. And this is tough. But then this little one here was exposed to sublethal rates, was able to reproduce and set seed. And this is problematic for resistance management. And here's a Waterham plant that was protected by the soybean crop. Our post-application happened a little too late, V4, V5 soybean crop. That crop was a little too big, protecting that weed a little too much. So timing matters. Smaller crops, smaller weeds, you have less problem with interception. And this is something important to keep in mind, okay? To wrap things up here, quick update on our resistance screening. We had 30 populations that came our way last fall. Many thanks to those of you who sent the seeds. The seeds were in the freezer until recently, so then we can overcome dormancy. And this experiment was sprayed yesterday. So yesterday we started our screenings with 2,4-D choline and list and Callisto, mesotrione. In 3 weeks from now, we're going to have the initial results available to you all, so stay tuned. And then lastly, I ask you to quickly grab your phone and scan this QR code. In this fall here, in the fall of 2024, Sam Beebe and our extension colleagues here, we want to offer you all a weed management workshop. It would be a full-day workshop in Arlington. What we want to learn from you is, would you come to this event in the fall, and what you want to learn about? So please scan this QR code. It's a 2-3 minute survey that Sam put together that's going to help us define whether you will come to attend this event, and what you want to learn, so we can build the curriculum for this day. So please scan this real quick. It's also going to be available in the chat, and I'm going to be sending this as an email later today, so you can provide us feedback, so we can put this nice full-day workshop for you at Arlington later this fall, okay? As always, thanks to our sponsors, supporters, and to the amazing team I get to work on a daily basis. Look forward to seeing you at some of our field days. We're probably going to have one in June at Rock County Farm, and then either July or August at the O'Brien Family Farm in Brooklyn. Stay tuned. You're going to be getting all that information via email. Thank you all so much.